Hello everyone and welcome to yet another recreation programming session with I'm Mr. Azodin. So on the previous stream we were developing Byte-Pair Encoding. It's actually a pretty cool algorithm that is used for tokenization in large language models. How about that? I bet you didn't expect that shit to happen, but that's exactly what happened. Right, and essentially it's a very kind of tedious process. It's not difficult to implement. The algorithm is actually kind of simple, but it's rather slow if you just implement it in a very naive fashion, right? So essentially you have to scan the text with a window of 2 characters, and you have to count how many times a certain pair of characters occurs, right? So, and then you replace the most frequent pair with a new token. And you save that in a table, right? For example, a pair AA is the most frequent one. I assigned a character Z on that pair, and I saved, okay, Z means AA. And then I repeat the process. And I repeat the process until I compressed it to not being able to compress it even more, right? So it basically exceeded the limit of compression. And now I have this table, right? And this is basically one way to tokenize this text, and this is what LLMs usually used. Well, it's slightly modified, not exactly that, but roughly like this. We implemented that. So I have in here, let me open the code base. I have a file, Discord logs. This is the logs from our Discord server. And look at the size of these logs. Yeah, so I don't remember when I started to collect these logs, but that's like a lot of logs. And I want to actually apply Byte-Pair encoding on that specific file. But unfortunately, it's dog shit slow. Right, so I can actually show you. So let's rebuild the whole thing. And I have a utility called txt2bpe. It accepts the text file, right? It accepts the text file. And then it also accepts the output, right? So where you want to output the result, this exact table, right? It will output this exact table in a binary format. And you just start this entire process, right? And it takes some time. It takes some time to, like, it reports the progress for every 100 iterations. We can wait a little bit, and I think one iteration here goes like for 1 second. We can maybe report it on each iteration. So let me actually go somewhere here. I think, yeah, so I can put 1 in here. So let's actually do report frequency, right? And this is going to be report frequency. I think I forgot to put T in here, and I'm going to put 1 in here. So then later I can modify this specific parameter. So before I can do that, I'm going to rebuild the whole thing. And as you can see, so this is the first iteration, this is the second iteration, and it's like 1 iteration for that specific file is more than 1 second. It is definitely more than 1 second. And I tried to leave this process off screen. It took an hour and it was still going. It was actually still going. So I actually canceled it, and I decided that I need to do something better than this, because the end goal is to actually compress the chat logs of the, of Discord. So maybe we can in crank cap optimization, but I don't think it's going to improve the situation that much. We can try, right? So let's actually give it a try. But I actually doubt that. So in here, we can do the following thing. So I can just do something like O3, right? So what about O3? So it's going to compile a little bit longer, obviously, but maybe it's worth it. Maybe it's actually worth it. So let's fucking go. Yeah, so it wasn't that long, but it was longer than usual. So let's give it a try. Okay, so it goes a little bit faster, but again, it actually went to several thousands of the tokens. I think 3,000 of the tokens, and it was not nearly even finished. It is faster, but I mean, I suspect it's kind of like a 10,000 of the tokens of the table. Right, so, and what I'm thinking is that we just like have to do something slightly different on a fundamental level, if you know what I mean. We probably have to do something slightly different on a fundamental level. So what's interesting is that I feel like some of the steps of the algorithm are parallelizable. And look at this Scheiße, meine Freunde. Look at this Scheiße. Do you see that? Do you see? Do you see? We have 16 cores. And when I start the process, what the fuck is this utilization of CPU? Bro, what the fuck is this? This is pathetic. Holy shit, this is so fucking 16 fucking cores. And what the fuck is that? Embarrassing. absolutely fucking embarrassing. I'm telling you, bruv, I'm telling you, this is absolutely fucking embarrassing. We have to do better. We have to do better. And I think some of the steps of this process are parallelizable to some extent. For example, we can count the frequencies in parallel threads, right? So we can split the text in chunks. We're splitting it in chunks, and we count the frequency in 16 separate threads, in 16 separate chunks, and then we can actually easily merge the frequency tables in a separate thread, in a single thread then, right? So, and I'm not sure how to parallelize the step where we take the original text and then replace the frequent pairs with a new token. I'm not really sure how to do that, but maybe parallelizing that step is not going to gain any, any benefit for us. Maybe one of the things we have to do, we have to measure how much each individual step of the tokenization process of a single iteration takes. I think that's a good idea, right? Just like measure, okay, so here is the process of counting the frequent pairs. Okay, here is the process of, replacing the frequent pairs with a new one, and so on and so forth. Just like see what is the most sort of like expensive step in here, right? So maybe the last step of replacing frequent pairs with a new one is not really that expensive, so it's like no point to parallelize that or anything like that. So that's going to be the topic for today's stream. So I plan to do that with maybe POSIX threads. I haven't worked with POSIX threads for quite some time, so this gives me an opportunity to kind of recall how to do that. So yeah, sounds good. Sounds Gucci. Sounds fucking Tamaguchi. I don't see any poggers in the chat. Let's fucking go. Let's fucking go. All right. So are we still actually going? I think, yeah, we're still going. All right. So it's, as you can see, it's still going. It's still fucking going. Right. And yeah, it's at the end of the hour, it was 2,000 new tokens that it generated for BPE. Right. So I don't think it makes any sense to actually, continue doing that. Oh, holy fucking shit, we have poggers in the chat. Yeah, fuck yeah, fuck yeah. Anyway, so let's actually acknowledge some subs. Thank you so much, Yatka, for Twitch application with the message Byte-Pair Encoding. Okay, cool. So Throbal, thank you so much for Twitch Prime with the message poggers. Poggers indeed. Poggers in the chat. Poggers in the chat. All right, so let's fucking go. How can we measure the performance? So every time I need to measure performance, I need to use this function clock get time or something, and I keep forgetting how to do that. And I actually use this function many times throughout my code base, right? So maybe, yeah, there's a lot of different code bases in here. Can I just like RG grab this entire, holy fucking shit, okay. So I have that libmil, but this is all not my code. Okay, so we have something in the, aha, maclock. So this is not my code, bro. This is all not my. How can I find my code specifically? So maybe I'm gonna do that in Sodium, because I do remember there was something like that in my code specifically. Right. So let's do vim grep. Okay. So mutualizer again. Oh, this is in BPE data, and all of that is in BPE data. Fuck, it sucks. I remember I just had a ready-to-use function that just grabs the time and also gives you the second and stuff like that, but apparently... Okay, so let's like not fuzz about it too much. So let's figure out how to use this entire shit. I think we need to use monotonic one, right? So this is a monotonic, gintonic, monotonic, and let's grab this entire thing. So text to BPE, text to BPE. So what's the first iteration? So what's the first step, I would even say? I think that's basically it. It's this one. Right, this one is just finding all of the frequent pairs, I think. Right, and like figuring out what's the most frequent one. Okay, so this is just figuring out what's the most frequent one. This is another iteration. And after we figured out what's the most frequent one, we create a new token and then replace. So there's 3 steps in here. Collecting the statistics, then figuring out what's the most frequent one, right? Finding the most frequent one. Though we can actually do that while collecting the statistics, I think, but it doesn't really matter. So it's a linear process, right? So we just merge this linear process into that, so it becomes kind of a constant. So I don't think it's worth it. So yeah. though merging it into, yeah, we'll see how it goes. Okay, so let's fucking go. We need to implement function something like get time. Maybe let's call it get sex, which gets the amount of seconds. Okay, so it gets the amount of seconds. Current amount of seconds. Classic, yeah, all-time classic. Well, I mean, I implemented this function multiple times. But I think I should add it to knob. Imagine having a function called knob gets. I should definitely add it because I knob gets. All right, so monotonic, clock monotonic, but that means I also have to implement it for Windows. Well, I mean, it's not that difficult, honestly. Right? Just implement that for Windows. Just implement that for Windows. I'm going to take that, and in here, it usually returns some sort of an error. And if you take a look at what kind of errors it may return, right? So in case of an error, it returns -1. Usually it's no access or TP, the pointer to the data, the return data points to an invalid memory, right? So which is not going to happen. This is our fault. Then providing an invalid clock ID, this is also our fault. And there's no device or something like that. It's kind of, there's no like really valid reason to fail for this clock unless you basically don't have an access to the clock. So I suppose in this specific case, we can just assert that return is equal to 0, right? So because like if any of these errors occurs, they're not really our fault. They're usually either a hardware fault or permission fault, right? So just like, if I can't do that, like I can't do anything, honestly. I can't do anything. So we can just assert that it will never happen. Time spec. Let's take a look at the time spec. So as far as I know, it's just like it has two things. Where's the time spec definition? I can't see that. Can I see the time spec definition? Why don't you show me? Why don't you show me that? Does anybody know where? Oh, okay, so here's the time spec. Here's the time spec. And it's basically two numbers. It's amount of seconds and amount of milliseconds. Okay. So I'm taking T, and it's a TV sec. And this is going to be just 1. And I have to add TV and sec. And since it's nanoseconds, I have to multiply it by 1, multiply by 10 in the power of -9. Right, so because this is nano, essentially. This one I can also probably, I don't know if it's a good idea to do it like that, but we can just cast both of these things to double and just return this entire thing. So this is basically returns the amount of seconds since some point of the clock, but it doesn't really matter, right? So we don't care about absolute time. We only care about relative. So let's actually do get sex. Let's do get sex, chat. Let's do get sex. So this is gonna be double begin, get sex. Then in here, what I'm gonna do is get sex minus begin, right? And I need to print the amount of seconds. So this is gonna be a long F because it's a double, and we can just print the entirety of it. So I'm gonna say sex, and in here, what we can do in here, collecting stats, and then we can try to repeat this process one more time. So here I'm going to do the begin again, and then print like finding most frequent pair, right? So this is where we figure out most frequent pair. We might as well even wrap this entire stuff into sort of scope, so it indents a little bit, but I don't really like how it looks like, so I think indenting it like this would be a little bit better, right? So I don't really like that it hides some stuff in the scope, right? So this is the first one, this is the second one, yeah, so all of that is super fast. This one can take some time, right? So let's do begin equal get sex. Right, so then we need to take printf, and we're going to put it somewhere down there. I'll put it somewhere down there, and let's indent this entire stuff. Boom, it didn't. Okay, so replacing the frequent pair. All right, that's pretty cool. So I think I want to make it like part of the reporting, but the reporting is done every like n iteration. So that means maybe we want to do some sort of an average thing, but I'm not sure. We'll see. So let me do the following thing. So I'm going to try to rebuild the whole thing and go through the compilation errors. I'm pretty sure there's some compilation errors in here, of course, because clock get time is probably located somewhere in time. Right. So it's probably located somewhere in time. Semicolon. Spend 3 hours debugging and was a single missing semicolon. Chat, laugh. It is funny. It is programming humor. Are you even a programmer if you don't find this funny? All right. So yeah, thank you so much. Yeah, it is funny. It's a funny joke. It's relatable. It happens all the fucking time. I forget a semicolon. I spent 3 hours debugging this shit. 3 hours debugging. Okay, so let's fucking go. So, and let's see how much time it takes. Oh, fuck. Classic. Like, people complaining about semicolons. How about new lines? Bro, how about new lines? Have you ever forgot, like, a new line? SMH my age. Alright, so let's try to rebuild. Maybe I can do something like nob. We're gonna do nob. Alright. And I feel like I was right. So the most expensive operation in here is collecting the stats. It takes half of a second with all of the optimizations. And then replacing the most frequent pair, it's not that bad, but I think if we can speed up this part, I think it's gonna be kind of cool. So yeah, how can, like, this one is actually super easy to speed up. This one is just, what's funny is that, look at this. This is how many tokens we have, right? And it's 33 millions of the tokens. This step is just a linear step of finding a maximum between the tokens. To be fair, we're not even iterating all of the tokens. We're just iterating the current table, which means that we're iterating actually to 156. Right, okay, so we're not iterating this entire thing. But then replacing, it's like iterating this one. And this one is even, it doesn't fit into 60 FPS, so yeah. Right, but this one is super easy to optimize, I think. To split between the threads. So I want to be able to maybe somehow not report things when I don't want to. So maybe we can introduce something like profiling. Let me think. We can, yeah, this one is kind of annoying. We can try to do the following thing. We can put all of this logic into some macros. Then, depending on the compilation variable, we can either include this logic or not include this logic. You know what I'm talking about? But that requires like having the variable defined somewhere, right? It requires defining the variable somewhere. So then I can do something like this, right? So basically I want to have macros, something like profile begin, right? So, and this is some sort of like sex, right? And essentially it's going to be sex, get sex. So that's what it is. And then we're going to have profile end. And it's going to accept the sex and the message, I suppose, right? So some sort of a, maybe label, let's call it a label. And then in here, where is this stuff? Yeah. So this is how we're gonna approach this entire thing. So we do get sex, then we do sex like this. And this is the label that we want to put in here, right? So this becomes the label, and now we can quite easily replace all of these things with just profiler begin, right? So replace that, and then profiler begin, boom, 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 boom. So this one requires a little bit more sophisticated regular expression. It requires a little bit more sophisticated regular expression, but maybe we can do that. Chat. Maybe we can do that. So let's actually think how we can do that. We want to extract this specific message. So what we can do, we can say, okay, so this is the group that we want to capture everything within this group. And then we're going to replace it with profiler and begin and that thing. All right, so I think this may work actually. I think this kind of replacement may work. So this is going to be, let's go to main, query replaced with the regular expression. I'm going to take in this entire thing. Did it actually find it? I feel like it didn't fucking work. I think it literally didn't fucking work, but okay. Yeah, it didn't find shit. I'm disappointed. Why didn't find shit? Because, god fucking damn it. So query. Yeah, it doesn't find that. Motherfucker, Emacs, stupid fucking Emacs. I remember this shit, bro. I don't want to use your stinking ass mini buffer to edit regular expressions. Just give me an opportunity. Oh my god. It escaped these slashes automatically. Motherfucker. Oh. I'm so fucking done. I don't want to retype this shit. Fuck you. Okay, well, I mean, I probably have to. Apparently, I am have to. Like, well, yeah, so this is correct. This is actually correct. Oh boy. Right, so this is, yeah, obviously. Fucking obviously. Sex, and this one has to be N. Maybe, yeah, well, I need to actually capture the entirety of these things. Very ergonomic text editor, by the way. Very ergonomic text editor. So, and then here, yeah, we replace that. And just, just a second. Finally. Almost, I forgot the quotes. Honestly, at this point, it would be easier to do that manually than coming up with a replacement for regular expression or something like that, you know? So when you try to solve a problem with a regular expression, right, so now you have two problems. Finally. Fucking finally. Yes, sucking cocks fallacy. Yes, sucking cocks. Exactly. That's what I'm doing right now. So anyways, I think this is what we can do. And now it should become super easy to actually like flip-flop between these kind of things, right? So if it's 0, right, so I can do something like this. It's going to be else, and then here I can just redefine all of these motherflippers and make them empty. Look at that. Like I'm just making them empty. They don't exist anymore. I said they don't exist anymore. Literally like this. So, and now I can just flip-flop. Enable profiling, disable profiling. Enable profiling, disable profiling. Isn't that cool? Isn't that cool? I think it's pretty freaking cool. Okay, so let's fucking go. So there's unused variable and it doesn't show profiling anymore, which is perfect, right? So, and I can reuse these kind of things now throughout the code base and very easily like replace the whole thing. I don't really like the fact that the variable has to define somewhere. We can maybe define it in here or maybe make it global, right? So we can kind of try to make it global, but that kind of sucks, right? So because if we're going to be working in a multi-threaded environment, so I don't really know, we can also make it thread local. So it's sort of like a thread local, so you're within the single thing. You are within a single thing. Oh, so you can use the like a for loop trick. Maybe that's a good idea, actually. Maybe that's a good idea. Some sort of for loop trick. But I don't think it's... It's actually not bad. It's actually not bad if you think about it. So, and in here, profile begin, it still has to save the variable somewhere. Let's keep it like that. Let's keep it like that for now. So, and because of this, right, so I'm going to remove the label. So now I'm just assigning to the begin, and I'm just using the begin in here, right, just using the begin. So I'm going to replace profile. You can't see shit because Emacs is being a big again, but it is what it is. Sometimes Emacs do be like that. Right, so I'm going to do it like this. Boom, boom, boom. Boom, boom, boom. And this one is also super easy to replace. So we replace this one with just this one. Boom, boom, boom. So let's try to recompile, and it seems to be recompiling. Okay, let's take a look at the subs. Let's take a look at the subs. Thank you so much, Nozik, for Twitch Prime location. Thank you, thank you, thank you. Really appreciate that. Okay, so the question is, how the fuck are we going to be actually parallelizing this entire thing? I have an idea. So we can basically give each and individual thread a chunk to work with. Right, we're giving each individual thread a chunk to work with. So we have a frequency table, right? And the frequency table just basically contains the like most frequent pairs. Let's say that we're going to have n threads, right? So let's call it thread count, and we're going to have let's say like 10 for now. So this is going to be a parameter that we can actually vary. And now let's introduce frec, right? So this is frex, and we're going to have one thing per thread. We could probably make it thread local, right? We could probably make it thread local, but I think it's just easier to just do something like that. And we're going to assign some sort of an ID to the thread so it knows which index it has to use, right? And each thread is going to have a region within the token in, right? Within the token in text, which probably means that this thing should also become like global. Right, and they're going to be processing that specific chunk of text into their own frequency. And as soon as all of the threads are done, we're going to be taking their frequency tables and we're going to merge them into a single one, right, into the full one. Should be relatively straightforward, I think. Should be relatively straightforward. Yep. So let's actually see. We're going to be using pthreads. Pthreads create, right? So there's this function which accepts the routine, the function that is going to be executed in a separate thread. And let's actually create such function. So how we're going to be calling it? So it's a thread that collects the frequency, freq collector, right? So this is a freq collector, and it also accepts some sort of an argument. Through this argument, we're going to be returning like maybe some sort of a data. What do we need? We need the index within the frequency array, right? We also need a range of the tokens from which to handle, right? So that's another thing we have to do. But what's interesting is that how I'm seeing that, like imagine we have some text, 256a, right? So this is the text. Let's maybe too much. Let's do maybe 64. Let's maybe have a global counter under a mutex. So we have a global counter under the mutex. So when the thread wants to take the next chunk to process, they log the mutex, they look at this specific cursor, and they basically allocate like how many tokens I want to process, right? And they basically take this specific range and unlock the mutex and continue on like their way. So essentially, threads are going to just query the chunk, then process the chunk, query next chunk, process the chunk, query next chunk, and so on and so forth. So that's basically the idea. At least for now. So maybe it's not ideal, but we'll see how we can improve it later. Right? Maybe we can do that purely in atomics. We'll see. So, but there should be some sort of like a mutex, like some sort of like a global counter that lets the threads know how much is already processed. Okay, and because of that, the only thing we care about is the index, right? So because of that, I think arg is going to be just the index. So uptr int, I think it's just ptr int. I think it's int ptr. What was the int ptr? What was the type? Does anybody remember? So the int ptr, it's just int ptr. Is it? Or ptr int? I don't remember. I think it's int ptr. Okay. So I want to cast argument to that. But we're on 64-bit platform, so let's just cast it to size t. And this is going to be our size t freaks index. So this is our index. So now we need this specific cursor that I was talking about, tokens in cursor, and it's currently 0. It is currently equal to 0. And we need a mutex. Is there something like pthread, paththread, pthread mutex t? Or maybe there was a create mutex. Was a mutex init? Yeah, it's a mutex in, but it didn't work because man is ass. Pthread mutex init. Yeah, there we go. So it destroy and initialize it out because it actually documents both of them. So we need to have some sort of a mutex in here, right? So let's say that this is going to be tokens in cursor mutex. Right, so that's what we have in here. So here's the cursor and here is the mutex. So for this thing to work, we'll need to include pthreads. That's our dependency, which makes it not compatible with Windows, but who fucking cares about Windows, am I right? I'm sorry. So we now need to initialize the mutex. This motherfucker accepts attributes. What the fuck are attributes? You didn't even document any of this stuff, bro. Wait a second. What the fuck is this documentation? Destroy initialize the mutex. Mutex attribute description. Refer to mutex destroy. Really? It's a separate page? Oh. Okay. So attributes. So init function call. Init function shall initialize the mutex references by mutex with attributes specified by attr. If attr is null, the default mutex attributes are used. Okay, so we're gonna be using null. I don't care about them. Like I don't know what kind of attributes you can put in there, so I suppose default is fine for me. Right, so I'm gonna copy paste this entire thing. I suppose it can also fail, right? So let's take a look at the return or errors. What are the possible errors? It's the wrong one, so you have to do. So return value. If successful, they return 0. Okay, that's actually perfect for me. That is actually perfect. Let's go to main. And I think we're going to start initializing when we actually start the process of, computing the frequencies. So let's do token in cursor. Tokens in cursor mutex. This one. And I'm going to put null in here. By the way, does it set error no to anything? Otherwise, the error number shall be returned to indicate the error. This one is interesting. So it returns the error code through the result, which is based, right? Not through the global variables or any of that soy shit, right? So it returns through the result. So let's do something like this. So this is going to be return, and if return not equal to null, it could be equal to one of these things. I suppose we can use str error to actually render it into human readable thing. Right, so this is going to be std error could not initialize mutex because of this stupid reason. Str error return, and then we're going to return with non-zero exit code. So this is one of the things we can do. All right, so let's try to compile this entire thing, just see what is going on. Okay, so everything seems to be fine. Everything seems to be Gucci, and in fact, Tamaguchi. So when I want to get the next kind of cursor, right, so I'm locking the mutex. So there should be pthread mutex lock, if I understand correctly. Pthread mutex lock. Okay, let's fucking go. So you can lock, you can unlock. What it returns? It returns 0, or it can error. The mutex cannot be acquired because the maximum number of recursive locks for mutex has been exceeded. Okay, so that makes sense, I suppose. But the only thing we care about is locking, and you can even try locking. Okay, that's very interesting. Shall be equivalent to mutex lock, except that if the mutex object referenced by mutex is currently locked by any threads, including the call shall return. It's like lock but asynchronous. Right, so you can check if it's locked, but you don't block. Right, so if you just lock, you're gonna block and only unblock when it's unlocked. Okay, so that's actually perfect. That's actually perfect. All right, so let's take a look at this stuff. So we're gonna do tokens in cursor mutex. So this is that, and then we're gonna unlock this and that thing. So using mutex for such thing, I understand, is kind of like very unoptimal, especially considering that we're dealing with a single integer. I think it would be better to use atomic tokens in cursor in here, but I just like don't know how to do that yet unless I have the exact algorithm that performs the thing that I need. As soon as I have this algorithm and it does what I need, I will think how to do that without the locks and stuff like that. Right. So this is a mutex lock and mutex unlock, and within this entire thing, we have to do some interesting stuff. For instance, we have to check if the tokens in cursor plus, we need to know the size of the chunk, right? So like, what's the size of the chunk that we want to process, right? So what's the size of the chunk that we want to process? How we're gonna call that? Frequency process frequency. I don't know. Like it's some sort of like a chunk size. Frequency collection chunk size, right? It's a very long name. I don't really like it, but I cannot come up with a better name for this kind of thing. So, and the question is, what's going to be the optimal chunk in here? I don't know. We can say maybe 1 kilobyte. How about 1 megabyte? Right. So in here, as you can see, we have 33 megabytes. So maybe 1 megabyte is too much, right? So how quickly can you process 1 megabyte in here? So for now, I'm gonna just put 1 kilobyte, right? 64 kilobyte, we can put 64 kilobytes, sure. Let's put 64 kilobytes in here. All right, so, and now we can just basically check. If I do frequency collection chunk size and it's greater than tokens in count, right, what is it going to be? So we get some sub. Dexas TTP, thank you so much for Tiwan's question with the message. Good luck for the multi-threading. Loving what you're doing so far with BPE. Okay, I hope I managed to decipher that. Thank you so much for Tiwan's question. 49 months. Damn. Thank you. All right. So, well, in case if it's less or equal. What we have to do, we have to come up with things like begin, right? So we need to have begin and end, right? So this is the begin and this is end. And we already have a freaking double begin. Let's call it begin sex. All right. So begin is going to be equal to this thing, right? Then we increment this thing by the chunk size and we say that the end is this thing. So essentially end is not really included in here. Begin sex, yeah, funny. All right, so basically that's if something else happened in here, so there could be like several situations in here actually. If token in cursor is greater or equal by itself to this thing, if it's greater or equal to this thing, that means it's time to actually stop, right? So it is time to actually stop, and I suppose we're gonna just simply like return out of that. But I'm actually not sure. I think this function should return something, some sort of like error indication and whatnot. Let me double check. So it was pthread create. No, it does have to, right? So it returns a pointer. So we do have to return something. So I suppose I can return 0. Let me see. I think it's supposed to return something that is going to be returned by pthread join. Yeah, so it is returned by pthread join, right? So the return value variable, right? So the return value variable. Okay. So that's pretty cool. So in this case, I'm going to return null because I have nothing to return, right? So it's kind of pointless. Okay, so, but there could be also a situation when we basically have a chunk, but that chunk is simply smaller, right? So that chunk is simply smaller. In that case, I suppose begin is going to be tokens in cursor, right? Tokens in cursor. Then tokens in cursor becomes equal to tokens in count, and correspondingly becomes that. and correspondingly becomes that. All right, so how can I merge all of that stuff together? How can I merge all of that stuff together? I think, and by the way, this is very important, you also have to unlock the mutex. You have to unlock the mutex. I feel like these two things could be merged like that. So essentially, this is what you can do. If it's less or equal, it's totally fine. We just do +1. If it's smaller than expected chunk, we're going to be processing a smaller chunk. And then we exit only if end greater or equal to the begin. Right, so basically that means you found the last chunk equal to 0. Well, I mean that means you have to stop. Right, so that's basically what we're doing here. Chunk smaller than expected. Yeah, chunk smaller than expected. Okay, so we locked, we got what we needed, we got the information that we needed, and now we are ready to actually process it in here. Right, so we're literally ready to process it in here. So what we can do, we can simply iterate from the begin to the end. Right, so size I, begin less than end. We do not include this entire thing. And now we have to just like process the pairs, right? So the very thing that we do down there, right? So we extract the pair and we add it to the frequency, right? To the frequency table, but not just like any frequency table that is corresponding to our thread. So I'm going to copy paste this entire stuff. All right. So we take the pair and we take I and I plus 1. So we kind of look ahead, right? So we kind of look ahead in here. And look, so if you have something like this, it's actually too much, 64. And you decided that the chunk that you want to process, how can I just, yeah, there we go, is this. So you're looking at this character and you're looking ahead for the next character because you only consider the pairs. Right, it's totally fine up until you reach the end. As soon as you reach the end, you actually go outside of your range. But this is something that you have to do anyway, right? So essentially, you may have a situation when two threads are looking at the same character. This thread like overflows a little bit, look at this character, and the next thread that also processes like the next chunk also looking into that, processing this specific pair. I think that's totally fine because we're not modifying tokens in. So we have two threads reading the same chunk of data, chunk of memory. It's just reading. There is only read operation in here. So I think in that case it's fine, right? So since we don't modify it, so it's totally fine. The problem I think happens when you're processing the last chunk, right? So the problem happens when you're processing the last chunk and you reach the end in here, right? You reach the end in here. So you kind of have to check for that. I think you have to check if I plus 1 is less than the tokens in count, you do that. Otherwise, if it's greater or equal, there is no next character in here. You kind of have to break out of the loop, right? So you need to have this kind of a guard in here. I think it does make sense. Okay, and then the rest of the stuff is pretty much similar, right? So you take the pair, right? Then you try to get the pair out of the frequency table. So in this case, you have to do something like this. So this is frex index. I kind of want to call it ID, right? So because it's just like a smaller thing. So here's an ID. This is another ID, and this is another ID, right? So this is what we can do in here. Yep. And after that, it's just done, right? And you kind of have to repeat the process, actually, believe it or not. You have to repeat this process indefinitely, basically. So until you reach this situation, and in that case, you just exit. You just exit automatically. So we can actually quite easily do something like while true, and definitely do this thing, and definitely query the next chunk, process the chunk, then query the next chunk, process the next chunk, until you ran out of chunks. So that's basically the idea in here. That's basically the idea. So I kind of want to actually make a setup where you only perform a single iteration, and see how much it improves the performance of that iteration. Yeah. So this thing could be actually in here. So then we have an ID, which is that. Okay. That's cool. That's cool. So, and the thing after the while loop, it's kind of unreachable. So maybe we can put something like unreachable. So and this is a frequency collector. some sort of a frequency collector. All right, so let's actually see if this entire thing compiles. Does it compile? Okay, so we have a pointer in here, which is rather interesting. So yeah, this is a now two-dimensional array, so we have to be a little bit careful. So if I have to so this is the frax. What was the original one? I need to have original code somewhere here. So this is frax, this is just frax, but then I have to do I, right? I have to do I because I found that okay, so I already use I for the range. It's already taken for the range. Do I shadow I here as well? Damn, I didn't notice that I'm shadowing the I. Fuck, look at that. I didn't fucking realize that I'm shadowing the I. For fuck's sake, and the compiler didn't even tell me. Bro, okay, so let's call it place. I think place is more reasonable name for this entire thing. Shadowing, yeah, shadowing. That's fucking, and I enabled all of the warnings and stuff like that. And looking at that, like, what the fuck is going on in here? I had shadowing so much, yeah. So what's funny is that, for example, something like Rust is kind of designed to like rely on shadowing a lot. Because this is the thing that you do in a camel. A camel is sort of like an immutable language. And for instance, in a camel, essentially you can't reassign the variable, but you can rebind it like this. So this is not considered reassignment. You're rebinding x to a new value, right? So it's still immutable. You're creating a new variable, right? And because of that, it kind of looks like assignment, but this is not assignment. It's a rebinding. It's you can't modify variable. It looks like modification. No, with pure functional programming language, you can't modify. Anyway, sorry, just like Rust, exactly. So we get some subs. We get some sub. Koster, thank you so much for tier 1 with the message. A good day indeed. Good day indeed. Mutability is evil. Sure. don't call our language mutable. It's not mutation. It's not mutation. Nah. Anyway. So yeah, that's pretty cool. Like I need to test this entire scheisse somehow. But to test this entire scheisse, I also need to have an array of threads. You know what I'm talking about? We need to have an array of threads. So let's do thread T, and this is going to be threads. So this is the thread count. We have as many threads as we want, right? As in threads count. So yeah. So this is a single iteration. Yeah. This is single-threaded. No, this is a single-threaded situation. What we want to do, we probably want to actually disable this whole thing, right? We disable this whole thing. And in here, we want to basically create n threads. Let's just start n threads. So this is going to be something like size t id from 0 to id thread count. And Emacs. Fuck you, Emacs. Thank you, Emacs. Very cool. So where's the pthread create? Pthread create. Let's do this scheisse. So here's the thread. So we have an array of threads for a specific ID. What are the attributes? I suppose the attributes do not matter. ATTR. Points to attribute, so we're going to use the default attributes in here, I suppose. Here's the default attributes. So then we have frac collector, so this is a frac collector, and now I can put null in here. So I just created the thread. And I suppose I can also check that if it's not equal to 0, we're going to just crash as usual. So mutex, I'm going to reuse the same code. Look how quickly I copy-paste the code. You don't need an LLM, chat. I keep saying, LLM is for people with skill issue who don't know how to copy-paste. That's right, I said it. What you gonna cry? You gonna cry? Shit your pants maybe? Anyway. Could not initialize, could not create thread. Let's fucking go. So we created some threads, and now I suppose what we have to do, we have to join on them. I'm a skill issue developer. Don't worry about that. Like, honestly, don't worry. It doesn't fucking matter. Right, so if at the end of the day you manage to achieve your goal fast enough, reasonably enough, who fucking cares how exactly you did that? Did you copy paste it? Did you ask LLM to do that? Nobody gives a shit. Nobody gives a shit. Your job is to solve problems. Honestly, after working as a developer for some time, I think the job of the software developer is actually to create problems for themselves to solve. So it's like it's an economy of problems. It's an economy of problems, and there is even evidence for that. There is even evidence for that because look at the World Wide Web specs. Look at the GPU API specs. They're absolute fucking shit. And I already talked about it. I have a hypothesis. I know that I'm schizo-ranting right now, but I want to schizo-rant a little bit, okay? So, and I have a hypothesis that all of these specs are shady on purpose to create a market for the frameworks, for web frameworks and game engines that solve the flaws of the original specs of the API. They don't make them good specifically so then the other people, or maybe the same people actually, the same people can sell you a framework that solves a problem introduced by a shitty spec, a shitty API. Okay, you guys are funny. For some reason, my keyboard fucking died. Fuck. Fuck, my mouse works though, somehow, but keyboard fucking died. Big API doesn't play nice, yeah, exactly, okay. So I wanted to zoom in quickly on this thing. Okay, thank you so much. The dynamic array guy. I am the dynamic array guy now, right? Spent almost 10 years delivering you content on all sorts of topics, on a variety of topics, only to end up being a dynamic array guy? Anyways, so bro, I have like hundreds of videos and VODs on all sorts of topics. It's just like, oh, it's the dynamic array guy. Haha, funny me. Congrats, you made it. Thank you so much, Leon. All right, so what do we have in here? So we have to join the threads. Better than a static array guy. Well, yeah, I have more elements at least. My array is longer, at least could be longer. It's just like, it looks small because it's cold. I mean, because nobody appended anything into it, so. Yeah, anyways, so let's fucking go. So what is this pthread join? Pthread join, and we just, okay. Can I actually put null into red val? Can I put null into red val? I think I should be able to. Is not null? Okay, so that means I can actually put red null there. Okay, let's fucking go. So let's do a threads, threads ID, ID and... Okay, no. By the way, does join automatically destroy the thread? Does anybody know? So function waits for thread specified to terminate if that thread has... My monitor has... Okay, so it's fine. So already terminated, the thread joins, returns immediately. So the thread specifies by thread must be joinable. What? You can have not joinable threads? Why? Why certain threads might not be joinable? Okay. If return value is not null, then blah blah blah, I don't fucking care. So if multiple threads simultaneously try to join, it doesn't say, do I have to destroy the threads after that? You can have detached threads. Yeah, like I'm thinking, do I want to detach them or do I, so you can have detached threads. So detached threads are not joinable, right? I thought detached threads just mean that they destroy automatically. Let me actually see. So where is the destroy? This is destroy mutex. I want to pthread destroy this thing. Maybe it's part of the create. I see. destroy. Is there some example? So you do join. Okay, you join the threads, but you don't really destroy it afterwards. So that means maybe join automatically does that. Okay, whatever. So I'm gonna assume that it automatically does that for you. All right. So red and what the fuck am I doing, bro? So this is going to be that, and let me copy paste one more time. Look at that. I'm copy pasting again. Could not join thread. So, and interestingly enough, now what we have to do, we have to join all of the frequency tables and stuff like that. Otherwise, it's not going to be equivalent. Right, so we just started the thread, we just waited for all of them. And I think creating threads over and over again is not a very good strategy. It would be nice to actually reuse them. So because of that, we'll need to have some sort of like a semaphores or something like that. Like in Jai, they're called semaphores, but I don't remember what they're called in POSIX, but we can actually look up Jai. Right, so if I go into the module, so there's a threads, and there's a primitives and a semaphores, semaphore. So let's find, okay, so it's a semaphore T. So this is a Mac OS implementation. We're looking for POSIX, I suppose. So this is Mac OS, but not POSIX. What is a SEMT? What is a SEMT? Is it defined anywhere? I don't really know. So let's grep. So I forgot the name of the is that a conditional variable or something like that? Whatever. Okay, we're gonna do that later. We're gonna do that later. So man seminit, seminit. Oh, it's like, oh, it's a part of the POSIX. Why doesn't it have POSIX prefix? Bro, freaking POSIX! I swear to God. Consistency, motherfucker. Oh, it's so old it didn't. Okay, POSIX. POSIX and Bayer. Oh, POSIX and Bayer. Imagine Richard Stallman bot. Richard Stallman bot replying POSIX and Bayer. Anyway, so this is probably what we need to do here. Classics POSIX. Okay. So and in here, GNU6. Aha. So after that, after we joined this entire stuff, we can actually merge all of these things into frec. You know what? I think I want to make a small break, chat. I think the time has come for a little bit of a small break because I need a cup of tea. Right, and after the break, we're gonna merge the result of the computation into a single table and see if it speeds up anything, right? Maybe not. Maybe there's too much overhead on creating the threads and so on and so forth. We'll see. Okay, let's make a small break and we're fucking back, my friends. So what we're gonna do in here, we need to iterate through all of the frecs. We might as well maybe even as we join the threads, just merge everything. Right, so here we free, I think we have to free regardless of whether we are like enabled multithreading or didn't enable multithreading, right? So we have to free that shit on each iteration. I don't really like that it deallocates, like literally deallocates the memory and doesn't reset the table, right? So it's just like a constant free and malloc, but that's the hash table that we're dealing with. So within the thread, do I also free my threads? My frequency tables? I actually don't think so. I think I should do that. I think it's quite important for me to do that. Yeah, so let's just go ahead and do ahm free frex ID, right? So we just clean up this hash table and then we start the process of like crunching the numbers. So after that, we wait for the thread. And we have to take its frex table, right? We're taking its frex table. You know what's interesting is that maybe the frex table has to be allocated within the thread and then returned through the return value of the procedure. So that way we don't have to create like a global array. I'll have to think about that. But I think for now it's just like easier to do it like this. So how, like we need to iterate through all of the elements of this thing. right, and append them into the global table now. All right, so how can we do that? I'm going to iterate size t I, and I think it would make sense to actually save the size of this entire thing to a separate variable, so we don't call this macro over and over again on each iteration. So it's going to be less than n, and then it's going to be plus plus I, and in here we do frax id I, and we take the value, right? And we have to actually take the key of this thing. So here is the key. And if I take a look at the definition of the pair, I think this is not what I should be looking at. I should be looking at the frac definition. So where is the definition of frac? So here it is. It's several of them. Yeah, okay. Key is a pair, right? So this is a key is the pair. I think what I have to do, I have to like load the key into a separate variable like this, right? And I need to find if that key exists in a merged frac table, right? So this is the frac. And what I have to do, I think I have to do hm get I, right? I get this global merge table. Maybe I should call it something different, right? So because it kind of looks similar to that global array. Look at that. Yeah. So I have a local variable and I have global array of variables, and the only difference in name between them is like s at the end, and that's kind of bad. I think that's kind of bad. I think what I have to do here, I have to call it like merged frac. But that actually created a bunch of error messages, right? So, but we can go through them and just fix them one by one at some point once I'm done laying down the foundation of the logic. So merged frac, and I need to get that specific key. And in here, it should return ptr difference t, which is the place within that hash table. So there could be two situations in here. If place is less than 0, that means there's no such key in the final merge table. In that case, what we have to do hm put, right? So let me find the signature of hm put. So hm put. So there was a variant that accepted not key and value, but the whole structure. I don't quite remember. I think, yeah, it was called puts. So it inserts the entire structure with the tk. Okay, so I can use puts, and I do merged frac, and I put the literally the entire thing in here like this. Right, so this is t, yeah. So that's pretty cool. But it's only when you can't find this specific key in a merge table. If we can find it, that's much more interesting. So we have to take that specific place, and to its value, we have to add the value of that specific frequency table. So that's how we're going to be merging them. So we're iterating that thing, and we're just like merging it into that. So that's how it works. I wonder if it's going to actually improve like performance of this thing. It's kind of interesting, actually. It's kind of interesting. And that's about it. I think that's about it. It constantly recreates the threads, but that's totally fine. And what I want to do, by the way, I want to perform only a single iteration. Right, so here I can actually put a condition iteration less than 1. Right, so actually, it's kind of clever that I put 4 in here, so it makes it super easy to just like, you know, add a condition, how many iterations you want. So we have also frequency report. I think I want to put it somewhere where we have thread count, somewhere here, like report frequency. Okay, so let me now go and try to rebuild the whole thing, at least confirm that it is buildable. Okay, so this is exactly what I was talking about. So now I have to call this thing merge frac. Let's go through the rest of the things. So this is threads. It doesn't like, it has to be a pointer. All right, so we have to pass it by a pointer. That's understandable. Okay, so this one is merged frac. So this is a merged frac. And in here now, it's a merged frac. Okay, so this is quite a few places in here, but maybe not that many, not as many as I thought originally. Merged frac. So here is another merged frac. So this is why I was hesitant when I wanted to rename this thing, because there's quite a few places where I use this variable. So renaming it kind of annoying. You know what I'm talking about? Like, you have one single variable which is used in many places and renaming it annoying. But maybe it's a skill issue, bro. Just use IDE. IDE. Sorry. But anyways, it wasn't that annoying though. I replaced it very quickly. Okay, so I'm a little bit afraid to look how exactly it works. So let's actually disable multithreading. Right. And of course, I forgot to actually like replace merged thing in a not multi-threaded version. Completely forgot about that. Yeah, it's a good idea that I tried a single-threaded version. Okay, that's cool. So let's fucking go. This is gonna be build text to BPE Discord log. Then we take the Discord log and we save it to Discord BPE. All right, let's fucking go. One iteration. It was one iteration, and it was relatively fast. I don't have profiling enabled though. So let's enable the profiling. Profile begin. Let's enable the whole thing. There we go. Okay, and that didn't work because I didn't recompile. All right, let's fucking go. Okay, that's cool. So collecting stats. So I don't like how it is formatted. I really don't like how it is formatted. Maybe it's fine, probably fine. So okay, now the time has come. We might as well actually save this entire thing because we can use these numbers, like at least like how many tokens we reduce, as sort of like a checksum, right? A sort of checksum that confirms that, you know, everything went okay. So, and we also know that it took 0.7 seconds to actually process the entire thing, collect all of these things. Okay, now we need to enable multi-threading. Multi-threading. Where was the multi-threading? Should have probably created a variable in here. All right, so here's the multi-threading version at least. So hopefully I didn't fuck up too much. All right, so I found... Well, collecting stats at least, okay, so... Classic. At least it's a segmentation fault. Okay? So, which means that one of the things I can do, I can go and do GF2. Right, so let's fucking go. And I'm gonna run with the same parameters and stuff like that. And it segfaulted. And where did it segfault? It segfaulted at merged frequency. That's very interesting, actually. So it didn't manage to... Yeah. So you telling me that merged frec didn't have anything inserted into it? That is fascinating. Okay, so it was freed. Then in here... Ooh. All right, so we went through all of these things and we should have actually appended some stuff into that. So it tells me that merged frec is literally empty. That's what it tells me, which is kind of bizarre. Which is kind of bizarre. So let me maybe take this thing. So print f. So this is going to be. Can I just take a look at the merged frec? So I can literally take a look in here. Merged frec. Optimized out. We have to be careful with optimizations, by the way. Maybe we have to mark something as volatile. Do we probably have to mark like global variables as volatile. I completely forgot about that. So, well, I mean, this one probably doesn't have to be marked as volatile, but some of the other things might be, actually. Some of the things like this, I don't know, like a token in cursor. Like, does it have to be volatile? I'm not sure. I'm actually not sure. Do we have any professional multi-threading developers in here? So do I have to mark anything as volatile in here? So volatile means that it's not going to optimize out reads and writes. And it will actually perform reads and writes, which is important for memory mapped input-output. So if MT, what is MT? What MT stands for? Could you please translate MT for me? memory transactions or what? I don't know. Multi-threading. Jesus Christ. Okay. So fucking. I thought it's something fancy. I literally thought it's something like memory transactions. Like, yeah, it's just like, okay, see. To be fair, maybe it doesn't really matter. So one of the things we can do in here, we can just print it at like the pointer, right? So I can't see that in a debugger, right? I can't see that in a debugger, but I can at least do printf debugging. So let's call it merged frec. And yeah, so this is gonna be just a pointer. I just want to see the pointer, right? So because it could be equal to null. It could be equal to null if we didn't insert anything into it. Memory transactions actually sound like a badass CS concept. Well, there is a concept of software memory transactions, right? So software memory transactions and all of the so software transactional memory and all of the thank you for Russian, and all of the pure functional programists like furiously masturbate to this concept. It's just like, it's fucking insane. It's just holy shit. Look, imagine PostgreSQL transactions. Now imagine you can do that on the variables. Holy fucking shit. So this is basically the discourse of like about STM in functional programming. So I don't know. So this is one thing I know. But anyways, yeah, let's actually print this scheiße and see if it's going to do thing. Okay, let's fucking go. It is new. This motherfucker didn't insert shit into our table. Fuck you. I wonder why. So if I take a look at the frecs, did I zero initialize those things? I didn't. Is that the reason? Maybe I should actually zero initialize all of these things just in case. But they are global variables, so usually global variables are automatically zero initialized, so I don't really have to do that. But maybe I do have to do that. Yeah. Okay, so now let's find the place where we do pthread join. So this is the size of the frecs. We can print something like this. So we, by the way, don't need this thing anymore. I know that it is empty. It doesn't have to be empty, but it is. So we can say something like zu n equal to zu. All right, so this is id n. Thread joined. So let's fucking go. And all of them are 0. Cool. So that means we didn't actually insert shit into any of these tables. Fascinating. Absolutely fucking fascinating. All right, so let's go. So this is a pthread create. So frec collector. Okay, so we just free this entire thing. That's pretty cool. By ID. Oh, motherfucker. Ooh, look at that. Look at that. So we're calling frec collector, but we don't pass any parameters to this thing. But this thing expects a parameter because it extracts the ID out of the parameter. So ID is equal to fucking 0. Absolutely disgraceful. Absolutely fucking disgrace. Anyway, so we have to fix that. We have to fucking fix that. Let's fucking go. So what we have to do is just like take d, ID, I mean, and cast it to pointer like this. Yeah. I'm sorry that I disappointed you. Anyways, let's fucking go. Fuck! Why didn't it work? Brovsky. Why didn't it work? Okay, so let's continue investigate. So that was not it, apparently. That was not it. Very fascinating. Very fascinating. So maybe there's something. Yeah, token in cursor or something. Okay. Let me do something like that. So we're gonna go deeper. We're going deeper. So this is gonna be n. This is another one, and we're gonna do frec collector zu, and this is gonna be id. Let's fucking go. Yep, it knows its IDs. It actually knows its IDs. Okay, that's pretty cool. So, and in here, every time we do begin end, does it know how, like, did it get them correctly? That's what I'm trying to say, right? Maybe it computes begin and end incorrectly. I don't know. So let's find out. So I'm going to put ID. So this is you, begin, ZU, and ZU. For those who doesn't know ZU, it's a format parameter for the size Z. Right, so size Z is different depending on the platform. On 64 it's 64-bit, on 32 it's 32-bit. So that's why it has to be kind of different to accommodate that. All right, so let's fucking go. So it didn't really work, so it's complaining about me not providing the ID. Okay, all right, so what do we have? Ooh, it never printed any of that shit. Classic, thank you very much. All right. We found it. Absolute coding. Absolute coding. Let's fucking go. Yikes. Did it even stop? Maybe I should have not actually removed this entire thing. So I wonder if it's like a nice optimization. Thank you. Thank you. But that's kind of the goal, right? So we're trying to see if it's going to help or not. So that's the whole point. All right. So, oh shit. Okay. So then it's supposed to exit. I feel like maybe it didn't exit. Actually, I think it has to be equal, right? If they're equal, it is also bad. It is also bad. Yeah, boy. But obviously, it took a little bit longer because we print some shit to the standard output, right? We print some shit into the standard output. Let's not do that. Let's not do that. So we also print in here. Okay, so I'm going to do that, and boom, it actually kind of finished. If you're already kind of looking at that, it improved it, because the previous was 0.7, which is kind of a shit performance, but this is only 10 threads. This is only 10 threads. What if it's going to be 16? So, and also we're printing to the standard output, so let's quickly remove all of the logging, right? So all of the logging in here is removed now. Yeah, it's actually faster, but not that much, honestly. Right, not that much. And also, let's compare the numbers. Did it decrease it by the same? Okay, it decreased it by the same amount. Right, so here was the original amount of tokens, then it went down to this, and it's the same as with the single threaded, which probably means that it's correct, right? It didn't break anything or and stuff like that. So, but this is only one iteration. What if we do 2 iterations, right? So because maybe we kind of don't reset the state correctly, right? Because we also have to clean up the memory. So here we clean up the memory and stuff like that. So let me see. Yeah, this is what I'm talking about, by the way, right? So it didn't reset the memory correctly. So something went terribly wrong. And I feel like this could be something with the threads. Probably after joining the threads, we have to destroy them. So let me see. Do we have destroy? So it's a mutual destroy man pthread destroy. Okay, how about create? Destroy. You don't really destroy, but I suppose you have to detach. Maybe you don't have to destroy. I don't quite understand. But anyway, so maybe what we have to do here, we have to look at where exactly it crashes, right? So this is a classic thing. It's a very much classic thing. So I'm gonna do gf. Just want to see where exactly it fails. Let's run with all of the parameters. Okay. Fascinating. So on the second iteration, it failed with this. Again. So this was the second iteration. So merged frac. This time it didn't optimize out and it's actually 0. Okay. So it's kind of funny why on the second iteration it didn't do that shit. Like why? Is that because it didn't create the threads or didn't initialize them, or what exactly happened in here? Because all that just means that all of these things went fine, right? So one iteration, as you can see, is totally fine, right? So it can do at least one iteration. This is not what I want. All right. So one iteration is fine. Second iteration, it already breaks down. It already breaks down. So it's a segmentation fault. Though collecting stat was fat, so that means it probably didn't receive that much stuff. Reuse the threads. We're gonna get to that. We're gonna get to that. Don't worry about it. I know. We didn't reset tokens and cursor. Yeah. Okay. Okay. Makes sense. So this is probably something that we have to do before starting the threads, right? So let's actually put something like this. We have to reset it to 0. Classic, exactly, classic. All right, so 2 iterations. Okay, so, and it's pretty consistent in terms of performance, so it's just 4 now. Okay, so what about, so threads count. We actually have 16 threads. What if I make 16 threads? Is it going to be faster? It's faster, but not by much, honestly. Right, it's faster, but not by much. So, and again, we're also handling this amount of like chunk. This is the chunks that we're handling in here. What about 1 megabyte? Right, so what if we handle 1 megabyte of these things? So we kind of went from 0.7 to 0.3, which is an improvement, but not a significant one, to be honest. This is not a 16 times performance. Because what a bargain, yeah, exactly. Because we actually keep recreating the threads. So there's probably a lot of overhead on constantly recreating the threads. So that's definitely a thing that we have in here. So let's try to not do that. Let's try to not do that. And we're gonna not do that by using semaphores, right? So context switching, maybe that's context switching, but anyway. Okay, so sem init. Is there a function semables? Okay, sem init. Initialize unnamed semaphore. Okay, so it has sem. All right, sem. Well, let's create sem. So somewhere in the same place where we have threads and mutexes and stuff like that. So this one is going to be, how should I call it? It should be the one that starts the, you know, the whole thing, right? So I don't know, collect frex. Is that a good name? Is that a good name? I hope it's a good name. So collect frex. So the parameter that we have in here is p shared. Argument indicates whether this semaphore is to be shared between the threads of a process or between processes. Okay, so 0 has that the semaphore is shared between the threads of the process. This is our case, so that means it's going to be probably 0. And should be located on the same address that is visible to all threads. Global variable, okay, so that's our case, So what about the value? You can have semaphores that between the processes, right? So, but we don't do multiprocessing. So the value argument specifies the initial value for the semaphore. Okay. But I thought it's just like sending a signal. So it's sort of like a variable, right? So semaphore is apparently a variable. I thought it's like a signal. Maybe what I need here is actually conditional variables. So maybe we need a conditional variables. Yeah, so is there something like pthread weight or signal? what was this thing? I forgot the name. What is that? Conditional variables in pthreads. I have to Google now. Pthreads conditional. This is what I want, right? Oracle. Yikes. Let's click on that. Pthread cond init. And then so this is the operations I need. I need wait and signal, right? So that probably means that I need conditional variables. It's just like in Jai they're called semaphores. So I don't know. So I kind of assume that they're semaphores. Like it's really confusing. This terminology is really confusing for me. Pthread init. What is it called? Cond init. Yeah, let's fucking go. I didn't fucking open it. Emacs. Cond init. Let's fucking go. All right. So you can also destroy this thing. So function shall destroy the given. Okay, but what about init? So a destroyed condition variable object can be reinitialized using. It's kind of interesting. Start an explanation about an object from a destructor, but not a constructor. It's a very creative choice of structure in your document, not gonna lie. Oh, and there's also pthread cond initialized. So in cases where default condition variable attributes are appropriate, the macro can be used to initialize condition. This is perfect. So chat, you know what that means? We can just like use this chassis. We can just use this chassis. This is perfect. So, and let's just call it collect frex. And it's automatically initialized, and we don't have to initialize that. That's perfect. Merge conditionals, conditionalizer. Okay. Very funny. I approve of that. Very funny. So essentially, how do we start? We basically just wait on this variable until we receive a signal. So let's do pthread cond wait. And as far as I know, it also needs a mutex. Damn, I don't remember it requiring a mutex for this shit. Okay. So there's also timeout, but we don't care about timeout. Shall block on conditional variable. The application shall ensure that these functions are called with mutex locked by calling thread. Otherwise, an error appears with mutex. Why do we need a mutex for that? I don't quite understand. It's automatically release the mutex. So I need an additional mutex just for that. Semaphores are what you want. Read sem wait and sem post functions. But I mean, conditional variables is also what I want. Okay, well, I'll give it a try. Sem wait. But why did they have to provide a value? You know what confused me? Is why the fuck do I have to provide a value? Wait and post as a wait. Well, I mean, if it is the case, I'm gonna use semaphores, sure. So in the post, yeah, increments. The value is the number of downs you can do without blocking. What is a down? I don't know. Do I look like a programmer or something? Do I look like a programmer? I don't fucking know. Okay, so value. Specify the initial value. It doesn't. So semaphores are ref counting for threads. Okay, so let me take a look at sem wait. So decrements locks the value pointed by sem. If the semaphore value is greater than 0, then the decrement proceeds immediately. If the semaphore currently has value 0, then call blocks until either it becomes possible to perform the decrement. Okay, so bro, I just want a conditional variable. So essentially, I want all of the threads to block on wait. Then from the main thread, I say go, and they all start from the other. Downs, decrements, increments. I don't give a shit. I just want all of them to block, and when I say go, they all go. I don't care what kind of counter it has inside of it or anything like that. Conditional variable sounds like what I need. Like, this shit is confusing, and I don't like things that I don't understand how to use. We use condition exactly. Exactly. Right, so it has this additional semantic of some sort of a counter that does downs and I don't need that. I want all of them to block, and when I say go, they all go, and then they go to this barrier again, they all stop. That's it. That's everything I want to know, I want to have, and if it has additional sort of whistles, I don't care about them. And in fact, these additional whistles kind of confuse me. I don't want to use them. That's why I didn't use semaphores. Does it make sense? Schizoid again. Yeah. So there's a p-thread barrier as well. P-thread barrier. I'm not a multi-thread. Oh, for fuck's sake. Fuck. Why there's so many fucking primitives to... What's the difference between conditional variables and barriers now? Like, why there's so many shit? Like, so much shit. I don't understand. Shall synchronize participation that in a barrier referenced by barrier. This current thread shall block until the required number. Ah, it's a different thing. It's a different. It's just they block until all of them are kind of synchronized, and then the I want the conditional variable. Yeah. Okay, I want the conditional variable. Welcome to multi-threading, where you have 7 solutions to one problem. I noticed. All right. This shit makes me want to schizo rant. So if you continue introducing me into more and more primitives, I'm gonna schizo rant again. Anyways, I warned you. I fucking warned you. So, okay, so here's the conditional variable, and what I want to do is condition weight, right? So, p-thread. This is why I don't listen to chat, because chat doesn't understand what I want. And again, so I don't like that it requires a mutex. Does it have to be different mutex? I can create a different mutex, but it's kind of weird that it needs a mutex. So it's kind of kinky, not gonna lie. But you need a mutex for this kind of shit. So this is conditional variable, yeah. So collect So chat, professional multi-threading developer, is it necessary to have a mutex in here? So we have to have both a conditional variable and mutex. Which raises the question, why conditional variable by itself just doesn't have a built-in mutex? Like, why does it have to be a separate thing? Just use bool in a global variable. So is it a mutex for reading the cond var? I see. That's very interesting. By the way, cond, wait, does it have any examples? Do you have any examples? Well, if you don't have any examples, you didn't have to tell me that. Just fuck you. Alright, cool. Fair. So p-thread mutex t collect frex mutex, and this one is gonna be just 0, not 9, 0. So here we need to initialize the mutex. Let's go ahead and initialize the mutex. So to initialize mutex, which one? Let's call it something like this, even though it's, well, I mean, yeah. So this one doesn't have to be like that. So frac collect frex mutex. And we're gonna say that we can't initialize this specific thing. Well, I mean, we don't have to say mutex twice. I don't think so. So collect frex mutex, and we just provide this thing. Do I even have to locate myself? I don't think I have to locate myself, right? Mutex. The application shall ensure that these functions are called with mutex locked by calling thread. Otherwise, an error. I need an example. I need an example on how to use this shit. Okay, show me an example, bro. Understanding pro condition wait. So there's a really. Okay, but I mean, this is not the final thing. Okay, so thread 1, I log the mutex while not condition do some. What the fuck is this shit? So why is while? Okay, do wait. I remember. Yeah, notify. Yeah, this thing. And as far as I know, they're part of the Java object, right? Aren't they? They're part of the Java object and just like send notify. And they're so fucking simple, aren't they? Yeah, look at that, bro. Look at Java. Look at fucking Java. Look at fucking Java. Just fucking wait. Just fucking notify. Bro, getting mocked by Java. Imagine getting mocked by Java. Like, for real. So fucking stupid. Rare Java dev. Exactly. Like, because, I mean, I programmed in Java professionally, right? So, I did use this kind of shit. And it's pretty convenient, right? There's like a previous of like a, wait notify. That's what we want. It's like, what the fuck is this shit? I should abandon freaking C and go back to Java, right? Everybody thinks that, oh, he's the C guy. Actually, I'm Java guy. I should go back to Java, I swear. Fuck this shit. Should have written the tokenizer in Java. Should have written it in Java. Okay, so let's go to Jai. Let's go to Jai. Jai implements semaphores, and semaphores are exactly what I want, and they're using sem_t. Right. So maybe I just like, yeah, maybe I need sem_t. So let's go there. So primitives. So sem_t. Okay, so semaphore. When you're initializing it, so it takes the initial value, but by default it's 0, right? So Mr. Jonathan Blow sets the initial value of sem to 0. And okay, so it is as simple as that. I still don't fucking understand what's up with this initial value or anything like that, but Mr. Jonathan Blow himself sets this thing to 0 by default, and that means we can trust that. That means we can trust it. Let's go back to semaphores. So let's fucking go. Damn. Honestly, like being in Jai beta is actually super beneficial in terms of having an access to all of the modules and gaining all of the knowledge directly from Jonathan Blow, right? So because he coded all of his knowledge in these modules, and it's not only him, right? So it's all of the engineers who work at Sokla as well. Friendship is over with conditional semaphore is new best friend. Exactly. That's what just happened live on Twitch at .television website. All right, let's fucking go. So we don't need any of these shites. Well, I mean, we do need it, but it has to be C_t, right? So that's what it has to be. So let's actually also make it 0 or whatever. And so let's go to the primitives. When I'm okay, so no, that's fine. That's fine. So when milliseconds are -1, the okay, well, I mean, okay, that makes sense. This is just looking for interrupts. It's like restarting the way. It's not busy looping, right? For a second, I thought that this is yet another busy looping. This is not busy looping. Look at that. Look at that. It only looks for interrupts. That's basically when the thread was interrupted. So basically it starts waiting again, which is actually kind of based, right? So this is a very based way of doing that. And I don't plan to interrupt anything. I think this is basically was created because this is a library function, so it has to be robust and reliable. So I think in our case, we can just like wait and don't care about interrupts or anything like that. So in C11, there is a new API for threads. Yeah, I know about that, but I kind of... Honestly, I'm kind of suspicious of everything that comes after C11, right? So, because the standardization committee of C, they literally don't give a shit about C. I think it was Siphonotera or somebody else on our Discord said that. Yeah, I don't remember who said that, but they consider C to be that annoying language that they have to support and make compatible with C++. I think it was Spearman. Yeah, it was Spearman. So essentially, they literally don't give a shit about C. For them, C is that little fucking annoyance that they had to support because it has to be backward compatible with C++. And they treat it as such. So, yeah. Did Rust folks hijacked it? Yeah, it's kind of like this is basically the result of design by committee, right? Big CPP ruins everything. Yeah. Anyways, so we are going to just wait. So, yeah. So this is the semaphore. Collect frex sem. I'm gonna call it sem. And it may return a result. And we're gonna assert that this result is not equal to 0. But maybe it has a different convention. I swear to God, if it has a different convention for returning errors. Does it say, fuck you! Not only it doesn't have a POSIX prefix, but unlike the POSIX prefix functions, it actually returns through error no, and it's part of the same library. I'm gonna start schizo-ranting. I'm gonna fucking start schizo... Okay. So essentially, so returns 0 on success, and the value of the semaphore is left unchanged, minus on return. Okay, so if this thing is going to be -1, we have to say something like std error. So could not wait on semaphore. Right, so, and what's the reason? By the way, chat, you can't see that, but my monitor is dying. It keeps going black for a couple of seconds and then returns back. So, and from time to time, actually, I'm typing blindly. I'm gonna put the board in here just in case. Right, because I'm not sure if exit is going to exit the entirety of the process. Does exit exit the entirety of the process? Go back to Debian. No, it's not a software problem. It's actually a hardware problem. So the problem is that I bought a new laptop and I have an old monitor, and it's so stupid. This monitor only supports VGA. Shut up. Shut up. Shut up. So instead of buying a new monitor, being a frugal person I am, I bought a cable from HDMI to VGA. Shut up. So, but it has some sort of a flow. Basically, when the voltage in the circuit of the apartment drops, like varies a little bit, it actually goes black for a couple of seconds and then restores again. So, and I kind of live with that. It went black again, by the way. Okay, so it's fine now. Did your laptop not come with a built-in screen? Well, I have 2 monitors, right? So, bro, like if you want to look at my setup, this is how it looks like. So this is my setup. So I have 2 monitors. This is the main monitor, and this is the laptop monitor. My monitor is so old, it has lower resolution than the built-in monitor of the laptop. So yeah, that's everything I have to say. And the reason why it is like skewed like that is because the monitor is a little bit higher, and the laptop is a little bit lower on the side. So that kind of represents how I see both of the monitors. Roughly. Anyways, a similar situation for you. I see. All right, so we're waiting for the semaphore. That's totally cool. But we have to do that kind of in a loop, if you know what I'm talking about, right? So it's yet another loop in here. Yet another loop. So but here, look at that. We are breaking. Yeah, we're actually not returning. We have to break out of this loop. So I suppose what we have to do is just break, right? So we're breaking out of the loop. Just a second, my monitor went black again. Okay, it's fine. All right, so essentially, as soon as you're done processing this entire thing, you break out of the inner loop. All right, then go on the outer loop back and go into waiting on the semaphore. Right, so that's roughly what I wanted. That's actually roughly what I wanted, and I think that's pretty good. So frag collector. And essentially here, and this is very important, we have to create all of the threads right away. Right, so let me maybe create a special variable in here that enables the multi-threading. So thread count, enable threads. Okay, so if 0, this is the threads. If not defined enable threads, we're using single threaded situation. If we enable threads, we're doing that. So that enables me, by the way, to now. So here we're initializing all of the mutexes and stuff like that. We don't need the mutex for conditional variable. Fuck that. Okay, that's pretty cool. So we already have return declared in here, so that's totally fine. We're just creating all of the threads, but only if we enabled multi-threading, right? So enable threads, and if enable threads, cool. We initialize the mutex for the cursor specifically. Then we create all of the threads. All of the threads, after being created, will wait on a semaphore, and we also have to create the semaphore, right? So sem init. So I already have it in here. So it is shared. So primitives. Let me see. So when you create it, it's just 0 and 0 in both of the cases. So we can actually set them as 0 in both of the cases. Here comes the 0, here comes the 0. Okay, so collect, frags, semaphore, pointer, this becomes return, like this, and we check in. Just a second, my monitor went black again. It's really sad that you can't see this, because I think you could actually take a little bit of a entertainment value out of that. Because it's kind of funny how it goes black from time to time. But this is something that I just live with, right? So this is something that I just live with. Okay, so we create the mutex, we create the semaballs, and we create the threads, right? So all the threads are blocked on the semaballs. Okay, so enable threads, if not defined enable threads. Okay, so this is totally fine. So the first thing, we have to set the token in cursor. And I think this is dangerous, right? So because I have all of the threads constantly running. So let's actually log the mutex. Let's log the mutex in here. Let me find, I can probably do something like that. So we're locking the mutex, and then we're unlocking the mutex. Right, and since we only use mutex for like a single variable in here, it probably makes sense to make it anatomic at some point. It does make sense to make it anatomic, I feel like. Right, but it's kind of difficult because we have two operations, like we have to take its value. Ooh, this is kind of cool. Is there an atomic operation that adds a value and returns old and new simultaneously? I never worked with atomic, but I think I kind of vaguely remember that there was something like that. Because I want in atomic operation, add a value to the variable and then get old and new one. Do we have any professional multi-threading developers? Because I feel like this is a thing in atomic operations. I think it is. Compare and swap, maybe that's what I need. So atomic, compare and swap. All right. Oh, okay. So there's a Wikipedia stuff for this. CAS. Okay. So pointer old, new. This one is interesting. Operation is atomic version of the following pseudocode where if p not equal old, replace it with new. Not exactly. I'll probably have to look into more different primitives. ABBA. It's a pretty good band. Anyway, so, but not for now. We can like optimize it a little bit later. So we set the cursor to null, and then I just do sem post. Let's go to the primitives. When you do post, you just post it, okay? So collect frax sem. All right, that's pretty cool. So you just post, and actually I have to wait now, don't I? That's a problem. That's actually a problem. So this is probably like a barrier situation. This is probably like a barrier situation. Right, so because post just posts and continues. It just posts a fetch and add. Okay, so atomic fetch add. I'm not going to be using it right now, but it's just like nice to know what kind of operations I have. Okay, so and it returns C, return this is the value object held previously. Okay. Yo, that's cool. Because I fetch it and increment that specific place in the memory atomically. And since I already have a fetched value within my thread, I can just add that value again within my thread without disturbing that value that is shared between all of the threads. This is cool. Okay. So you also have atomic exchange and stuff like that, right? So I just read it and add it simultaneously. Right, so that results in the add operation being done twice in two separate threads. This is cool. Right. So it is added twice, literally, in once atomically and then non-atomically within a single threads. Okay, I'm learning things. Thank you so much, Ed. It's an atomic plus postfix. Yeah, it does feel like it. Atomic plus. Alrighty, so, but semaphore actually created a problem, right? So because now I told the threads to go, but now I myself have to wait until they're done. And I feel like this is where we need to have a barrier. Don't we? I think that's where we have to have a barrier. Threads create problems. Yeah, exactly. I do agree with that. They do create problems. But I mean, we didn't have that problem before. It's just like I'm trying to have like a thread pool, so to speak. But maybe this is exactly what I should have done instead. All right, so pthread pool. So pthreads pool. How to utilize a thread pool with pthreads. So I just realized that what I'm doing in here is just like a thread pool. You telling me there's no thread pools in pthread? Chat, is this real? There's no thread pools in pthread. I thought they do exist. Fuck. Correct, you make me... Okay. Well, we'll continue making our own, because that's literally what we're doing here. Okay, so pthread barrier. Pthread barrier. I suppose I can... Maybe I can do man pthread barrier. Okay, so man pthread barrier create... Oh, there is a destroy though. Okay. So initialize a thread, pthread barrier. Maybe we can do example. Show me an example on how to do that. Pthread barrier usage example. Okay, so initialize thread nums. Okay. So then we create n threads, and thread nums is 4 of them. Okay. All right. So all subthreads. So if I understand correctly how barrier works, right, so you wait on a barrier and it increments the counter within the barrier. As soon as the counter reaches a certain number, it unblocks everybody. So that's how it works. Did I understand it correctly? I think I understood it correctly. So this is the last piece of the puzzle. This is the last piece of the puzzle that we need in here. Yeah. Synchronize a barrier. Shall synchronize in the counter, the call threads shall block until the required number of threads have called. Right, when the required number of threads have called wait, specifying the name of the constant thread shall be returned to one unspecified thread, and 0 shall be returned to each of the remaining threads. At this point, the barrier shall be reset, and this to the state it has as a result of the most recent barrier init function that referenced it. Okay, so I think I do understand how all of that works. So let's create a separate barrier, I suppose. So, and because this is literally what we need, right? Semaphore is to sort of start the whole thing, and a barrier to sort of synchronize. Okay, so what was the destroy? Destroy barrier. So this is the creation. So this is pthread barrier. So collect frags barrier like this. Okay. So now I have to initialize this entire thing and enable threads. So initializing mutex, initializing the semaphore, initializing the barrier. All right, let's fucking go. So collect frags barrier. We're almost there, chat, by the way. We're almost there. Null. And okay, so threads count. So it's a thread count +1. Why +1? Because we also have a main thread, right? So we also have a main thread, and we want all of the threads, including the main thread, to synchronize on wait and then unblock simultaneously, right? So that's what we want. That's what we want. Pause. Yeah. Okay, so we didn't manage to initialize the barrier. So this one. And that's very Gucci in my opinion. So essentially what we do, we post the frags start, and then we're waiting on the barrier. I feel like we have to call them differently. I think we have to call them collect frags start, right? So semaphore is a collect frags start, and a barrier is collect frags end, right? So semaphore is responsible for synchronizing, for starting the process of collecting the frequencies, and the barrier is responsible for synchronizing for ending, right? This is very important, I think. This is very important. So collect frags barrier. There we go. So we started and we're waiting on this thing. All right. So now in the workers, as soon as we started in here, right? So here we started, then we do that in a loop, and then we end it, and this is where we have to put this barrier. Right, so we end it, and we're waiting for the rest of the threads, including the main thread, to reach that point, and then all of them unblock, right? And the workers go back and block again on a semaphore. This is cool. Because of that, I feel like, so this thing has to be called start, right? So this is going to be sem start. Maybe I'm going to call it like this. Actually, frags start semaphore. I still want to kind of indicate, monitor again, I'm sorry. I still want to indicate that it's a semaphore, so it's going to be frags start sem. Yeah, there we go. And this one is going to be frags stop. This one replaced with stop, but it's a barrier. So we can have a little bit of a Hungarian notation in here by including the type of the variable in the name of the variable. Not sure how good of an idea that is, but maybe it doesn't matter, honestly. Or, I mean, the compiler is going to tell us if we're just like using this thing incorrectly. So we don't have to include that in here. So we'll just call them start and stop, and we'll make it a little bit more readable. Wasn't sure if I want to go that route, but I think it makes sense. I think it makes sense. Okay, so let's try to compile this entire thing and see if it's going to compile. All right, let's go through the compilation errors. SemT, unknown type. Okay, sem init. Not only it is Man, did they just smash two different libraries together and called it pthreads? Is that what actually... Anyways, so I guess they did. I guess that's literally what happened. It's Hungarian. It's similar to Polish notation. Well, yeah. If Hungarian notation doesn't work for you, try Russian roulette. I'm sorry. Anyway, okay. Let's actually set one iteration. And try to see how it's gonna work out for one single iteration. All right. So let's fucking go. Fuck. It didn't work. All right. That's very interesting. I wonder what happened though. I wonder what happened. So let's actually see. So this is a sem init. Okay, so what if we have 0 iterations? What about 0 iteration? Okay, so it didn't log anywhere during creation or anything like that. Wait, okay, so threads are enabled. So that's perfect. So on a single iteration, maybe I should just step through in the debugger, but I'm kind of lazy, so I'm going to be using this kind of thing. All right, so foo, so new line. So this one shouldn't log. Okay, so sem post, then pthread barrier wait. And this one is basically merge. All right. This one is basically merge. Joining the threads is not needed if you're using barriers. Okay, I found it. We don't need logging. So it was joining on a thread, but thread is not supposed to quit. Obviously it hang. Right. Fucking obviously. So you don't do that. All right, so you just wait in the barrier, and after that barrier, you know for sure that all of the threads are blocking on the semaphore, so you can just like collect all of these things. Okay, that makes sense now. Right, let's try to recompile the whole thing. Fuck! Okay, so, excuse me. Let's do the debugging. Okay, so this one is pthread barrier, wait, merge. So it was not that, or maybe not only that. Let's put it this way. So merge. Okay, so it was not only that. So pthread barrier, and then it basically hangs on the barrier. So that's basically what's going on. It hangs on the barrier. All right, so there's this stop. So let me double check. So when we initialize, it's just that. And then we're waiting on the barrier. Let's find other places. Yeah, so this is stop. That should just work. Okay, so there's something. Sem post only unlocks one worker. Really? Do you think it's only one worker? Really? So that's how it works? How do I unlock multiple of them then? You have to post the number of threads. So let me take a look. Sem post. Increments unlock the semaphore point to by sem. If semaphore value consequently becomes greater than 0, then another thread. Fuck. Yeah. But then how do I reset it back? Sem posted create. All right. I mean, I can do it like that. All right. I can go through all of these. So when the semaphores doesn't even accept value, right? So yeah, doesn't accept the value. So threads, what is it? Thread count, right? But then on the first iteration, they're all incremented and all and stuff. And then on the next iteration, do I have to reset that counter? I don't quite understand what's the point of that counter. I don't quite understand what the point. For how long I can increment in it? I really don't understand the point of this entire thing. So let me see sem weight. In decrements. Post increments it. Weight decrements it. So I incremented n times, and every time it incremented, one of the weights gets triggered and decremented, so they're constantly. Bro, Java notify weight. Bro, Java notify weight. I swear to God. Why it is not like that? Just notify. Wait. Oh, not you. Yeah, that's true. Okay, forget everything I said. Anyway. So, yeah, let's actually comment out stuff. I know how to program, I swear. All right. So, fuck, I forgot to increment. We survived one iteration. How many threads do we have? Threads, yes, 16 of them. We survived one iteration. That's pretty progress. That's pretty cool. And let's try to survive two of them. Iteration. So for something, yeah, this one. Can we survive two of them? Okay. All right. So what about? It's kind of like 0.2 is better than nothing, at least, because if we just set one thread, so now we can like quite easily like control, right? So if we want like single threaded, we can just put thread count 1 and it's going to be basically single threaded. Yeah, so it only improved the performance like 2x, unfortunately. It only improved the performance 2x. What if I decrease the size of the chunk we're working with? Maybe it somehow depends on the size of the chunk, but I mean, we also have to increment the size of the count. Yeah, so, well, it's 25, but if it's this, okay, it's 25, and it becomes slower. So 256. What if it's 256? It stays the same. 512. 512 is kind of an optimal thing in here. All right, so that's pretty cool. That's pretty cool. So now, I feel like one of the expensive operations is HM free, because we constantly free this entire thing, which is not good in my opinion, which is kind of not good. One of the things we can try to do, actually, I just realized, we can reset the fracs by iterating them and setting their values to 0. Bro. Out of context, syndrome of searching for deep meaning. Odin, TS, Odin, all streams data programming Odin. You won't believe how fucking cursed this shit is. You know how you call a combination of Zig and Odin? Zodin. Anyway, I should. Bro, I must create a programming language and call it Zodin. Yes, I think the universe, the simulation is telling me that the time has come. I must create new programming language called Zodin. It's a sign, exactly. It's a fucking sign. Zodin. The time has come. Anyways, so what I was doing, I forgot what I was doing. So yeah, several iterations and shit. Several iterations. Yeah, okay. So not freeing the freaking hash table. So HM free, HM free. So essentially, if this entire thing is not null, instead of freeing the memory, doing free malloc and stuff like that, let's iterate like this. So obviously I probably want to have something like n, which is the size, which is the length, so I don't recompute it over and over again. So it's going to be n plus I, and I just do frex id I value equal to 0. Look at that. Look at that shit. I think there's something to that. HM free. Yeah, wait a second. I didn't copy it properly. So that way we never free. That way we never free. Which is good. And we reuse the memory that was allocated. Merged frac. Look at that. That's pretty pog. That is pretty pog. That is shit, because the keys are completely different now. The keys are completely different. Yeah, so it has to be freed. It has to be freed. Yeah. Unfortunately. If frac. If there was a way to just reset the whole table, but I don't think there is. So there is only free, stb free. Maybe we could write an allocator. Yeah. So one of the things we can do in here is actually use some sort of arena, right? Allocate all of that stuff in arena, and yeah, mem set to 0. All right, so let's actually unconstrain the amount of iterations that we have in here, right? So we are unconstraining this entire shit. Let's compile it and see how quickly it goes. It goes relatively quickly, right? So, but it's still gonna take some time to compress all of that stuff. It is still going to take some time, right? So, oh, but by the way, let's try this shit. Not bad. That's a pretty good utilization. That's actually similar to utilization when I do FFmpeg, honestly. Right, so all of the chords are utilized. Yeah. When I do FFmpeg with like when I'm using FFmpeg to render my VODs, this is kind of the picture I see. So I guess we kind of parallelize that. Not even leaking memory, exactly. So the memory is where? I don't know, where's the memory here. I think that's what it is, yeah. That's the memory, it's not leaking. And where are we? So this is already, yeah, it's pretty, yeah, iteration 200. I feel like I'll still have to leave it like for a couple of hours to finish compressing the entirety of the log, right? Because the log is 30 megabytes. And yeah, it's going much faster for sure. It's going much faster, but I wouldn't say it's that much faster. So yeah, that was an interesting session. We learned about multithreading and different primitives of multithreading. So what I'm gonna do, my next plan, I'm going to, like, off screen, what's log? It's a Discord log, right? So it's a Discord log, which is like 33 megabytes, right, of our Disco server. Right, so off screen, I'm gonna let the process go, maybe think about better ways to like do the hash tables and stuff like that. Right, I'm gonna compress and I'm gonna build the BPE table. I'm gonna try to build the BPE table. And once we have the BPE table, we may try to do another session where we use that table to generate, schizorand based on our logs, right? So because that's kind of the point, right? So because the BPE tables, I think this is my hypothesis, they kind of encode the grammar that they implicitly derived from the text, right? So then you can use that grammar to generate more text that looks like that text original one without using any LLMs or anything like that. Just using the LLM tokenizer can already have a little bit of a grammar from which you can generate something, right? So this is kind of the hypothesis that I'm trying to prove or to demonstrate or something. Is BPE like WordVec? Nah. BPE is an algorithm for splitting text into tokens that then can be used for WordVec, right? So essentially, I suppose it's more like a token vec in that case. So you're converting into vectors the tokens that you derived from the process of BPE, right? WordVec next. Not really. So I'm developing BPE specifically to confirm my hypothesis about BPE. But then once we have it, we may try to do WordVec, right? So for WordVec, like what exactly? There's different algorithms for WordVec. So Word2Vec. So you need a lot of text to actually, derive any meaningful vector space out of that. Yeah. We'll see. We can try to do that. So doing a WordVec on the Discord logs is also kind of interesting. Small language model, yeah, exactly. So WordVec might be better implemented in Python Keras. Bro, I don't know what is Python Keras, but I'm 99% sure that whatever it is using is implemented in C anyway. And Python is just like a front end for the actual C code that's doing the heavy lifting. I'm not interested in that. If I actually want to learn something, I want to actually implement it from scratch. I want the real thing. So it uses backend. Exactly. So nobody fucking uses Python in AI. People think they do, but in reality, all the serious code that is doing any heavy lifting is written in C, C++, Rust, and Fortran. Those are the languages, the main languages, industrial languages. Right. Python is a fucking toy. Python is a Slack driving the racing car. Exactly. AVX time to optimize this. I was hoping that maybe the compiler will do all of these optimizations for me, but I'm not sure how we can use that. So what we're doing is essentially just, collecting statistics. We're not doing anything particularly special. Is this on GitHub yet? No. I'm gonna publish it on GitHub once I'm ready. Right, once everything is ready, I'm gonna publish it on GitHub. I don't want to publish it just yet. The content is not ready. All right, so do we have any recreation programmers streaming right now? So the compiler won't generate CMD on its own. You need to enable. Okay. So fair. Let's give it a try. Before I go, let's give it a try. Maybe it will work. So knob.c. So this is O3 and arch. Okay, so just knob. Okay, so let's fucking go. The performance is pretty much the same. Yeah, I don't think that's the bottleneck. I mean, thank you. I think I'm gonna keep this specific instruction. Also, I saw some people suggesting fast. We can also try to do that. Nah, doesn't prove anything. I think I need to do some sort of profiling to figure out what's the bottleneck. But my hypothesis is that it's the hash table, right? So the fact that I can't just reset the hash table and reuse all of the memory that is allocated by hash table is kind of a bummer. Or maybe I should probably code a very specialized hash table for my application. I think that's what I need to do. Yeah. So STBDS is probably my biggest bottleneck, but yeah. Okay, so do we have any recreation programmers that's streaming right now? So let me see. Do we have any epic recreational programmers? Valigo is streaming. Okay, so let's actually rate Valigo. He's probably what is he doing? What is he doing? Jaime game development. Okay. Let's rate him. Oh, by the way, I can just rate it from here. Rate Valigo. All right. Okay, get ready for the rate, boys and girls. Get ready for the rate, and I see you all next time. Love you. Mwah.